Hello everyone, welcome back to my channel. So in this video we'll see some of the problems based on PCM. Okay, two problems based on PCM. So if you are first time to my channel, please consider subscribing. So I have explained you clearly the concept of PCM and the mathematical formula, mathematical equations which we require in order to solve the problems like this in my previous 3 videos. If you have not seen that videos, please pause this video here and go to there, because I'm providing the link in my description playlist link in my description. So go there, see those 3 videos, understand the concept of PCM and note down the mathematical formula, and then come back here in order to solve these problems. Okay, right. So in this problem he has given that a message signal whose amplitude varies from 0 to 10 volts. So message signal amplitude is varying from 0 to 10 volts. That means what is this represents? Vmax, message signal maximum value. And what does this represents? It represents Vmin. Okay, that is the first inference. Next, is band limited to 4 kilohertz. That is, this message signal is band limited, that is the maximum frequency W, or we can call it as FM, anything. Okay, so it is equal to 4 kilohertz. Okay, right. So that is the maximum frequency of message is 4 kilohertz and transmitted through a channel using 5-bit PCM. 5-bit PCM means n is equal to 5. N is equal to 5. Next, the sampling rate is 50% higher than the Nyquist rate. Okay, the sampling rate is 50% higher than the Nyquist rate. Then calculate all the parameters of PCM. Okay, so we know that Nyquist rate is equal to 2 FM. Okay, so Nyquist rate is equal to FM. It will be 8000 samples per second. 8000 samples per second. But he has given that the sampling rate is 50% higher. 50% higher than the Nyquist rate. So sampling rate is equal to, so it is 50% higher. So when it is 50% higher, how can we write it? It will be 150 by 100 times of 8000. So this represents 50% more. Okay, so 100% means 100 by 100 means it is same as Nyquist rate, but it is 50% more. So I am writing 150 by 100. Okay, so these two gets cancelled. So what you will get is 12,000 samples per second. 12,000 samples per second. So this is sampling rate, that is 1 by TS. 1 by TS is the sampling rate. So it is given by 12,000 samples per second. Okay, so now first of all, step size. Okay, step size. What is step size? So n is equal to, first is quantization level. So n is equal to 5 we have. Second is L is equal to number of quantization levels is equal to 2 power n, which is equal to 2 power 5, that is 32. Next, third is step size. Step size is Vmax minus Vmin divided by L. So what is Vmax? 10. Okay, and Vmin is 0. 10 minus 0 is 10 divided by 32. 10 by 32 volts is your step size. Next, fourth, QE maximum value. QE maximum value is 1 by 2 into step size. 1 by 2 into step size is equal to 10 by 64 volts. Okay, and QE varies from minus del by 2 to plus del by 2. So range of QE is from minus del by 2 to plus del by 2, which is minus 10 by 64 to plus 10 by 64. This is fifth point. Next, sixth is RB. RB is equal to n into 1 by TS. So it is 5 into 1 by TS is 12,000. So it is 60,000 bits per second, or it is 60 kbps. So this is RB. And the last point is bandwidth. So bandwidth is equal to RB. Bandwidth of PCM is equal to RB, which is equal to 60 kilohertz. 60 kbps, here it is 60 kilohertz. That is the bandwidth here. Okay, so this is how we can solve a problem if you understand or if you remember the formulas which I have explained you in my previous video. Okay, so just as application of the formulas, I have taken this problem. Okay, so next we'll see one more problem on PCM. Okay, so in this problem he has given that there is a sinusoidal signal which is band limited to 5 kHz and transmitted through a channel using PCM, and sampling rate is twice the Nyquist rate, and has given a condition that maximum quantization error should be 0.1% of the peak signal amplitude. In that case, he is asking you to find the bit rate RB. Okay, so he has given that there is a sinusoidal signal, that is m of t is a sinusoidal signal. Okay, let this be a sinusoidal signal. So its peak amplitude, let us assume that it is AM, then its minimum value is minus AM, that is Vmax here is AM and Vmin is minus AM. Okay, so that is the inference from this graph. Okay, then he has given that the sinusoidal signal is band limited to 5 kHz, that is FM is equal to 5 kHz. So once you have FM, we can find Nyquist rate. So Nyquist rate is equal to 2 FM. So it is 2 into 5000, that is 10,000 samples per second. 10,000 samples per second. So once you have Nyquist rate, we can calculate sampling rate. So what he has given, sampling rate is twice the Nyquist rate. So 2 into Nyquist rate. Okay, so 2 into 10,000, which is equal to 20,000 samples per second. Sorry, 20,000 samples per second. Okay, so you have got 1 by TS. Right, see this condition he has given, the maximum quantization error, that is QE max is 0.1%. 0.1% means 0.1 by 100 into 0.1% of peak signal amplitude. Peak signal amplitude is AM, so maximum value here is AM. So what is QE max? So we know that QE maximum is equal to del by 2. And what is del again? Del is equal to Vmax minus Vmin divided by 2. So Vmax minus Vmin divided by L here. Sorry. So del is equal to Vmax minus Vmin by L. So del is equal to Vmax is AM and Vmin is minus of minus AM by L. So is equal to 2 AM by L. So send this to this side, so it will be del by 2 is equal to AM by L. So what is del by 2? This is QE max. QE max. So from this equation I am writing here. Okay, so QE max, in the place of QE max we can substitute with AM by L. So AM by L is equal to 0.1 by 100 into AM. Okay, so AM and AM gets cancelled off. So L is equal to 100 by 0.1 is equal to 1000. So when you have L, so we can calculate N. So 2 power N is equal to 1000. So N is nearly equal to 10. Because N is an integer value. N should be an integer value. It cannot be a fractional value. So I'm assuming this is nearly equal to 1024. 1000 is nearly equal to 1024. So that's why I'm taking n value as 10. Okay, even though if you are getting a value which is nearly equal to 10, you have to round it off and you have to take the value as 10 for each and every problem. Okay, so now we have n value and 1 by ts value. Now we can calculate bit rate. And bit rate is n into 1 by ts. So it is 10 into 20,000. So it is 200 kbps. Okay, so this is how we can solve a problem based on the condition given. So in order to solve this, we need to get the concept perfectly, that is QE max value. Okay, so QE max is equal to del by 2 and del by 2 is this. Okay, so this is one of the important model for the questions to be asked in competitive exams regarding PCM. Okay.